So far, we have seen several different ways on how to find the zeros of a polynomial. The zeros of a polynomial are determined by the factors. And given the factors of a polynomial, we know how to obtain the original polynomial by FOILing them out. But we have yet to go from a general polynomial to the factors completely. In this section, we introduce polynomial division to simplify our higher degree polynomials. Let's go ahead and look at an example of polynomial division. Given x minus 1 is a factor of the polynomial x cubed minus 3x squared plus 3x minus 1, completely factor f of x. We'll use polynomial division to solve this problem. Let's first set up the division symbolically. We're going to divide x minus 1 into the polynomial x cubed minus 3x squared plus 3x minus 1. To divide the polynomial f of x, we want to take our term x minus 1 and multiply it by some number here so that we get rid of this x cubed here. Let's go ahead and multiply x minus 1 by an x squared, then multiply x squared by x minus 1, and we'll get x cubed minus x squared. Now go ahead and multiply our x cubed minus x squared by a negative 1 and then add it to the term above it. The x cubes cancel out, and we're left with a 3x squared plus x squared, which is a negative 2x squared. Go ahead and bring the 3x down. And we want to go ahead and repeat the process. We want to multiply x minus 1 by some number such that we get rid of this negative 2x squared. So multiply x minus 1 by a negative 2x, and this is then going to become a negative 2x squared plus 2x. Multiply this entire term by a negative 1 and then add it to the term up top. And the negative 2x squareds cancel out, and we're left with a 3x minus 2x, which is just x. Go ahead and pull this negative 1 down. And to get rid of this x here, we're going to multiply our x minus 1 term by 1. So let me go ahead and rewrite this a little bit to the side. So what we should get is an x minus 1 times an x minus 1, where we multiply that by a negative 1. Then combining x minus 1 with our negative x minus 1, we're left with 0. What this tells us is that the function f of x is going to be equal to an x minus 1 times an x squared minus 2x plus 1. Now we can go ahead and factor this term here, and we see that this is going to be equal to an x minus 1 times an x minus 1 times an x minus 1. And this is our polynomial completely factored. Before we look at the general definition of polynomial division, let's look at another problem. Here we want to divide 16x cubed minus 12x squared plus 20x minus 3 by 4x plus 5. Again, set up our division. We have 4x plus 5 will divide into 16x cubed minus 12x squared plus 20x minus 3. We want to get rid of the 16x cubed, so we want to multiply the term 4x plus 5 by a 4x squared. This is going to give us a 16x cubed plus 20x squared, and multiply this term by a negative 1, then add it to above. Our 16x cubes cancel out, and we're left with a negative 12x squared minus 20x squared, which is a 32x squared with a negative in front. Bring down this plus 20x, and we continue our algorithm. So now we want to get rid of the negative 32x squared, and so we want to multiply 4x plus 5 by a negative 8x. This is going to give us a negative 32x squared minus 40x. Oops, I have one too many x's here. Let me delete that. Now, again, multiplying this and combining it with the term above it, our negative 32x squareds cancel out, and we're left with a 60x. Go ahead and pull this negative 3 down. And to get 60x, we're going to multiply 4x plus 5 by 15. This gives us 60x plus 75. Multiplying it by negative 1 and then adding it to the term above it, our 60x's cancel out, and we're left with a negative 78. since negative 78 doesn't have any x terms, and the degree of negative 78 is less than the degree of 4x plus 5, we're done. What the division algorithm tells us is the following. The polynomial 16x cubed minus 12x squared plus 20x minus 3 is equal to 4x plus 5 times 4x squared minus 8x plus 15 minus 78. So far, the term that we've divided by is called the divisor. The term we get after dividing is called the quotient. And the remainder of the division is called the remainder. It's possible for the remainder to be a polynomial, to be a real number, or even to be 0. In this case, our remainder was negative 78. And the term that we begin with before we do any division is called the dividend. Oops, I misspelled that. Let me respell that. There we go. Now let's state the division algorithm. Given a polynomial f of x and a polynomial d of x which is non-zero, where the degree of d of x is less than or equal to the degree of f of x, then there exist two polynomials, q of x and r of x, such that the following condition holds. Furthermore, where we have that the degree of r of x is less than the degree of d of x. Here, this term is still called the divisor. Our q of x represents the quotient, and r of x is our remainder.